Today we're going to talk about intro to systems of equations. This is an 8th grade concept that I want to bring back in to make sure that we fully understand. So to start this off, Jules opened a checking account with $500 and plans to spend $50 each week. Astrid opened a checking account with $50 and plans to save $25 each week. An equation showing the relationship between x, the number of weeks, and y, the account balance, is shown for each account below. Graph each equation and use the graph to answers A through C. So they did go ahead and make these for you, and what I want you to notice is that they are in the form y equals mx plus b. Perfect. Now, why that's important is because I do have a graph and I have an equation. In order for me to be able to put those on there with full confidence, we like the form y equals mx plus b because I have that slope and I have that y-intercept. So I'm going to actually highlight those in the colors that I'm going to need. So here's my slope, and then here is my y-intercept. So now when I go look at those equations, I can highlight the things that are in those specific spots. So that way I kind of know what I'm doing here. Perfect. Alright, so now we're actually going to plot these points and draw their correct lines. So we'll do Jules in pink here. So Jules is a negative 50x plus 500, meaning that her line will cross the y-axis at that 500. And then because her slope is negative 50, that does mean she is going down, and negative 50 is an integer, so we're going to put that over 1. So we're going to go down 50 over 1, just like that. You don't have to draw any more points. Once you have 2, you are able to draw a line. You just want to make sure your line is pretty precise. There we go, making sure I'm on there. Oop, I think I went a little bit perfect, drawing the line down just like that. Okay? But make sure you put the arrow at the end that shows that your graph could continue on forever and ever. Now we're going to do Astrid, and I will do Astrid in this sort of green turquoisey color. So hers is y equals 25x plus 50. So I know she'll cross the y-axis at 50. And then because she's going up by 25, that means we're not going to go all the way. We're going to go about halfway, but still over 1 because, again, that integer, or in this case, that is a natural number. Now, if you want to be on a solid point, or a perfect point as we call it, you are allowed to continue that one. So that way that 2 and 100 hit. So now I'm going to draw another line just like that. Now, the purpose of this was because they gave us 2 scenarios here. They gave us Jules and they gave us Astrid. I just wanted to plot the points here because they gave me a graph. Why not utilize my resources? Now let's answer the questions. Where do the graphed lines intersect? Oh, well, that's pretty simple. You have an ordered pair in the middle of the x, and that ordered pair is 6, 200. Oh, I don't know why I just wrote that. 1 second. And I'm back. Whiteout is my best friend. Sorry, I meant to make that a comma and then write the number 200. Perfect. It does say, what does the point of intersection represent in the context of the situation? So at this point in the class, we would kind of have like an open discussion of what was going on. So what I want you to notice is that the x-axis is in weeks, but the y-axis is in the balance, meaning the amount of money. So in this case, after 6 weeks, both girls will have $200. Okay? Then it says, prove that the point of intersection is a solution to each equation by substituting the values in the equation. So just like y'all have been doing when you're temporarily changing numbers, that is what this one's wanting you to do. It's wanting you to double check that when you plug in 6 and 200, 6 in for the x and 200 in for the y, will you get the same numbers on both sides of the equal sign? So I will do joules. Let's just go ahead and do joules. So her equation was y equals negative 50x plus 500. Instead of y, I'll change my color here. I'll do pink. Instead of y, we'll put 200 equals negative 50 times the x, which is 6, plus 500. And if you plug that into your calculator, you would get 200 on the left and you would get 200 on the right, making this a true statement. The same thing would happen for Astrid. So if you want to do that off camera, you're more than welcome. I'm going to pause the video and do that myself. Hopefully that you work this out by yourself and you see that when you substitute in those x and y's, you do get the same number on both sides. Now, the reason that this works is because that is the point of intersection. That is where these two lines will be the same, which now introduces us to systems. All this means is that two or more linear equations that use the same variables form a system of equations. Now, the solution of a system of a linear equation is the ordered pair that makes all the equations in the system true. All you are trying to do in this unit in linear equations is trying to see where your lines intersect. Do they intersect? Do they overlap? Those are the types of things that we are looking for. So here it says when a system of linear equations is graphed, we can find the solution to the system by looking at the point of intersection. In examples below, graph the system of equations. Find the solution to the system and check your solution by substituting. Now, I'm not necessarily going to require you to always double check. That is what you have a calculator for. What I need you to understand is two things. Number one, when you're graphing, your form needs to be y equals mx plus b. That is your standard form for a graph. If you are in that form, you can go ahead and proceed and plot the points. All systems mean is you're going to have two equations, or sometimes more, but most of the time it's just two. You're going to have two equations at once. You plot the points and draw their lines. You're trying to decide where do these intersect. So I'm going to do number one with you, negative x minus 2. I'm going to do this one in my green color again. Now, negative x minus 2. That minus 2 is your y-intercept, as we discussed above. So I'm going to put my point, but then that negative 1. So I'm going to write this equation. Y equals negative x minus 2, where this is my y-intercept, and my slope, because there's no number there, I have to remind myself that there is that invisible 1, that this is negative 1 over 1. So I'm going to go down and right 1. Perfect. Draw your line, connecting those points just like that. Draw your arrows through them. And then your second line, do that one in my purple here. Y equals 1/2 x plus 7, where this is my y-intercept, and here is my slope, 1 over 2. So we're going to plot a point at 7. we're going to rise 1 and run 2. Or if that's a little too close to the top for you, you can go down 1 and left 2. Just like so. Draw your line of intersection. There we are. And from there, it becomes quite easy to see that these lines do intersect. If my line had been a little bit higher, it would have hit perfectly, but they intersect right here at -6 and 4. So that is truly what systems means. It's, can you take two linear equations, plot them at the same time, and figure out that point of intersection. So moving on to number 2, where it says y equals -5, and then y equals -2x minus 3. So this again is in the form y equals mx plus b. Now, when I look at y equals 5, let's go ahead and bring that down again. Y equals -5. I want you to notice that there is no x, meaning that that -5 is not a coefficient. It is not being multiplied by anything. It is simply staying at -5. So the only way that I can create a line that stays at -5 is if I draw a horizontal line. It only crosses that axis at that number. Because notice if I had drawn it up, meaning vertical, I would have hit every single one of these y values. I can only hit the y value of -5 based on what my equation says. Now, the next one, which we're going to do in our purple color again, y equals -2x minus 3. This one does have an x, so that means that I have a slope. This slope is 0 because there's no x there, and this slope is actually -2 because that -2 is in the coefficient position. So the slope is -2 over 1, and your y-intercept is -3. So we're going to plot our y-intercept first, -3, and then I see that the slope is -2 and 1, so I'm going to go down 2 over 1. And in this case, it was actually quite easy to see my point of intersection. Draw my line just like so. There we go. And that intersection point would be right there. So 1 and -5. So hopefully this makes a little bit more sense. So now we're going to go on to our second page, where I'm going to pause my video and I want you to attempt 3 and 4 completely without me. Perfect. So hopefully now you've attempted these on your own, and you can see that on number 3 we had two linear equations in the y equals mx plus b form, so they were pretty simple to graph. But then on number 4, I see this x equals 6. So with that being said, a while ago, whenever it was y equals, we drew a horizontal line because I only hit the y axis at that number, whereas this is a 6 and it says x equals. So yes, we have an x, however, it's not an x that has a coefficient. It's actually an x equals equation, meaning that I can only hit the x-axis at that number. So this would be my case of an undefined slope because I can only cross the x-axis at 6. And then whenever I plot the linear equation, 2/3 x plus 3, they intersect at 0.67. Y'all are so funny. I can just hear it now. So we are going to skip around here, and let's go ahead and go on to question. Let's look at question 5. So it says Pedro is 10 miles from Sam's house and is driving at a rate of 0.5 miles per minute to meet Sam. Sam leaves his house driving at a rate of 0.75 miles per minute to meet Pedro. The system representing the situation is shown. Guys, with systems, all it is two scenarios going on at once, and you're trying to figure out what these two things have in common. So just like with the things above, it is literally what you were just doing, but now they've just tacked on some words. Do not let the words be what overwhelms you. Stick with everything that you know. Plot this line first, this line second. So if you prefer to see slope as rise over run, you know that 0.5 is actually just 1/2 x plus 10. And then of course you have y equals, and then 0.75 is 3/4 x. Your calculator will convert those for you, but I do understand that some people really like to see rise over run. I'm one of those people. I need to see it. So now I can plot those lines at 10, and then I go down 1, right 2. There we go. Draw a line. Making sure my lines are nice and crisp here. There we go. Oops, sorry. Now you're going to do the same thing with the bottom. Y equals 3/4 x. Now this line, on the other hand, does not have a plus b. Hopefully at this point y'all are able to say, oh, Miss B, that's proportional. That goes through the origin. There's no y-intercept, therefore it is a proportional line. Now we're going to perform the slope. Up 3, 1, 2, 3, over 4. 1, 2, 3, 4. Perfect. Now I can draw a line connecting those two dots. And you will see that you intersect at a single point, meaning that you probably already have your answer. It says graph the system and find its solution. Again, it's solution. Do they intersect? Do they not intersect? Do they overlap? This one, they intersect at a single point. And that single point is 8, 6. Then the question says, what does the solution mean in the context of the situation? So mathematically, you can do it, yes. You can make sure these are in y equals mx plus b form. Do rise over run and do your y-intercept. But then now the word problem part. Can you put words to what just happened? Of course you can. 8 is on the x-axis. 8 represents the minutes. So these two boys are leaving a house. So after 8 minutes, both Pedro and Sam will be 6 miles. And again, the miles, they cross at 6, and this is on the axis with the miles. 6 miles from Sam's house. So again, it is no different from anything else with linear equations other than can you put words to what you did. And guys, at that point, you're golden, and I don't feel like we need to go any further. If you have any questions, please just let me know. Thank you so much. Bye.